Production and factory settings bring their own set of hurdles for wireless connections. Harsh conditions, both indoors and out, create a daunting task for engineers to work through. Now let me tell you, those engineers ain't looking to back down from a challenge like this, no sir. This here's where we gather round to tackle them hurdles, swap thoughts, and lend a hand. Welcome to the Industrial Wi-Fi Shop with your hosts, Scott and Jeremy.
Hello, everybody, and welcome to episode 18 of the Industrial Wi-Fi Shop. My name is Scott McNeil, and with me, as always, my podcasting partner in crime, Jeremy Baker. Say hello, Jeremy.
Hello, everyone. How are you doing this evening, morning, afternoon, or whatever it is where you're at?
I honestly believe that's the most you've ever said when I've asked you to say hello. That's amazing, sir.
Social pressure works.
Social pressure is a thing, faux show. This episode is the magic of BLE because Bluetooth Low Energy is absolutely insane. But before we dive into all the fun stuff, a couple housekeeping things I want to talk about. Jeremy still has his 3D printer plan for the Oscium WiPry and the Clarity. Was it the Clarity and the Lucid? It'll work for both of those, right?
Yep. And there's one for the 900 megahertz one on there too.
Okay, awesome. And that's hosted on Thingiverse. We have the link in the show notes. So if you have a 3D printer and you need a copy of those plans, you can download them there for free. WiCo, we got a couple of events coming up it's still a couple months out, but in September on the 10th and 11th. So it looks like WiCo London they're calling it UK South in London, is another 2-day event like it was last year. So WiCo London is getting really, really big, which is awesome. And then in October, on October 1st, we have another WiCo in Canada in Montreal. If any of you guys are in those areas and you're listening, go sign up and check those WiCos out. The content is great. These are smaller events, so they're more cost effective for all of us who can't make it to the really big conferences. And because of the quality of engineers and people that are going to these things, the presentations are current, they're relevant, and it's interesting material. And you're seeing it from vendors, you're seeing it from individual users, you're seeing it from integrators. The ones that I have been to have been fantastic. I've presented at 2 here in North Carolina. It's been a lot of fun. And then the networking that comes with it on top of that. So WiCos are always worth the investment. And again, because they're smaller, more localized events, the cost is much, much lower. And it's a whole lot easier to get the boss to pay for it, right?
Absolutely. You can also talk them into letting you bring a couple of your coworkers.
That's true, because it's a bargain, what a bargain.
And if you're feeling like really frisky, you can submit to give a small presentation at them too.
Well, and that's what it's all about, right? Sharing information. We're not information hoarders in this community. We got to share it out and help educate one another so we all become better. It's not going to get better unless we make it better, right?
And at the smaller events, it's less people you have to imagine in their underwear.
Or actually show up in their underwear. So it depends on which one you go to.
That might be like a WiCo Vegas or New Orleans.
Well, what happens at WiCo Vegas stays at WiCo Vegas. They don't share that out, so we'll never know unless you go.
Oh, dude, a WiCo at the Sphere, that would be
insane. That would be an expensive one because the Sphere,
get one of the spectrum analyzer companies to sponsor it, and then just put spectrum captures up on it.
Ooh, that'd be cool.
That'd be pretty sick.
And then they would go to that eyeball like it was looking at you. That just kind of creeps me out a little bit, though. The other day, Brian Tuttle from Metageek reached out to me to let me know that the update that they are going to drop on Monday, July 14th is a great update that is going to give Chanalyzer channel display packages for both Bluetooth Classic and BLE. So now you'll have the option of looking at 802.11 Wi-Fi channels. You'll have the option of looking at Zigbee channels. And finally, after giving them a bunch of crap, they put it on their radar, and Brian built it, and he says it's looking really, really good. Now you're going to be able to look at either Bluetooth Classic channels or also BLE channels, which is absolutely awesome. It gets kind of hard sometimes when you're looking at spec in and you want to identify those coordination channels, and they just kind of they sit off far enough on the Wi-Fi channel base that it kind of makes you feel unsure, even though the signature matches exactly what you're looking for. It's kind of hard to identify if it's really sitting on that channel or not because you have nothing to gauge it by. But now you will. So now you're going to know if it's sitting on channels 37, 38, or 39, for BLE. And that's awesome. So in the show notes, we also have links to Joel Crane's in really awesome creation for looking at different channel space. And it's at spectrum.potatofy.com. That is in our show notes. And you can drill down and you can look at all those channels and you can get familiar with it. He did a fantastic job with that. But the really cool thing is it's actually kind of a living project. So he constantly makes changes to it and tweaks it and improves it. So kudos to Joel for sharing that out to the communities. FOC, free o charge, or as Jeremy says, his favorite price, free
Free 33. That's right. And
Yeah,
also
I
another
do listen to you, Jeremy.
That's right. Another good thing about that too is that it's not just for like Bluetooth. It's basically like the whole, 900 up to the new like Wi-Fi 6, the 6E frequencies are in there too.
I think he has plans to like expand it out to even further to ultra wideband and whatnot too, but I'd have to ask him about that. I just remember hearing him saying something somewhere about that, but I could be wrong. I could be delusional. It's getting a little late and I can't have caffeine anymore. So who knows what's going to come out of my mouth at this point. So today we are talking about Bluetooth with more of a concentration on BLE, Bluetooth Low Energy. And today we have with us from Onyx Inc., the incorrigible Tobias Meyer, straight off the boat from Germany, decided to come hang out with us instead of like go somewhere cool like Washington, D.C. or something. And so Tobias, can you tell everybody a little bit about yourself and something about Onyx?
Sure. First of all, thanks for having me here tonight. And hello, everybody. So yeah, I'm one of the founders of Onyx Inc. The Onyx Inc. actually stands for Automation Network Experts. What we're doing is industrial networks, automation networks. We're focusing on wireless solutions. In the portfolio, we have, beside the Bluetooth we are talking about tonight, 900 megahertz radios for long distances. We have Wi-Fi clients for Wi-Fi 6, Wi-Fi 4. We have access points. We have all the routers and switches you need, firewalls, PDP, grandmaster clocks. And something special about the PRP radios. But this is what we're doing. Onyx was founded in 2023 inside the United States, longer before it was in Europe. And the idea behind Onyx is actually to look out for the best hardware solutions for the customers and implement and service them in the United States, Canada, and Mexico.
Awesome. So we get the power of German engineering, but the salesmanship of the US. That's fantastic. So, just as long as you're not promising Uber gigawatts on the box like most marketing people do, because that's what everybody runs for.
Well, as long as they can do up to 1.21 gigawatts, we're good.
Well, that's the key, right? That's kind of like your magic number, right? 1.21 gigawatts. If you can reach and attain that, then you're pretty much golden for any deployment you want to try and put it in. So before we get deep into the dark depths of really some cool stuff that Onyx has been able to do with BLE, I just kind of wanted to refresh everybody about some basics about Bluetooth in general. So most of our wireless community should be pretty familiar with everything. Our OT people, I'm sure you haven't really, sat down and read the BLE standard or anything, the paperwork that the Bluetooth SIG puts out. unless you're really just trying to get your eyes to bleed, or you really wanted to go to sleep early, because that stuff will just knock you cold out. But in essence, what it all comes down to is we have, and it's kind of deceptive how they number it, but you have 4 classes of Bluetooth, right? So your class 3 that maxes out at 1 milliwatt. Its range is very short, a meter, 3 feet, maybe 2 meters, and it's for wearable stuff. It's fitness trackers, it's watches, it's different things that are directly on your the ever popular PAN, right? The personal area network. That is what these devices are for. So then that jumps to a class 2, and you more than double the power output. So you're going from a 1 milliwatt max to a 2.5 milliwatt max, so about 4 dB. Your typical range is up to 10 meters or 33 feet, and this is probably the vast majority of what everybody's used to out there, right? This is your AirPods. This is keyboards and mice and all these different accessories that everybody uses that's Bluetooth, that syncs up your phone to your car, whole 9 yards. Class 2, by all means, is probably the most common use of Bluetooth out in the known universe today. Then you go to a class called that they identify as class 1.5. So again, we're increasing the power outputs up to 10 milliwatts or about 10 dBm, because there's really not a clean calculation on that, but it gives you a little bit more range, about 20 meters or roughly 65 feet. The applications of this are, some specialized headsets and some smaller mid-range devices. It's not very common. Sometimes they group it in with class 1 as far as specifications are concerned, which I'm not sure why, because it's a big jump in power versus the standard, class 1 versus 1.5. Because when you look at class 1, you're looking at a maximum output of 100 milliwatts. So that's 10 times the power allotment. That's a pretty big deal. So I don't see really, unless they're just struggling to find a place to put it and they didn't want to give it its own full numeric designation. They're like, sure, we'll just kind of shuffle it in there as like, we'll do 1.5. This will be class 1's little brother, right? Instead of giving it its own real designation. But class 1's really what we're going to be talking about today. And that class 1 is what BLE falls into. It's got a max power output of 100 milliwatts. Your typical range is about 100 meters, or roughly 330 feet. And it has quite literally a metric ton of use cases for it, and anything from sensors to industrial equipment to I/O, which is shorthand for input-output devices, machine-to-machine communication, and different things of that nature. And with class 1, and this should go without saying, it will only work with other class 1 devices. I think that's kind of, a given. If you don't understand that X Bluetooth version will only work with X Bluetooth version, that's kind of the par for the course. But really, originally Bluetooth was an IEEE standard, but it quickly got kicked over to their own special interest group because there was so much to it. And I don't know if IEEE just got tired of keeping up with it, or if the special interest group just wanted to do a whole lot more with it than IEEE was prepared to do with it. Either way, they were like, okay, here, you have it. It's all yours. So now it's fully controlled by the Bluetooth SIG, which, as with a lot of these things, kind of similar to wireless HART, it's a conglomeration of all these different manufacturers who have their input in the development of that protocol, which I think is pretty cool, that all these private companies can actually sit down and not be hostile to one another, because it's all a bunch of competitors to help develop and move that standard forward. So that's one of the cool things about our whole capitalist society that I really like a lot. Because they want to make their money, but everything has to be kind of interoperable. And unless you're going to sit down and play nice, you're not going to be able to accomplish that. When you look at it in the basics, higher power does allow for greater range. That's really kind of the gist I really think that's the main point between these different classes is its power. how much power you're allowed to kick out per class per device. But that kind of dictates the hardware that those devices are built out of. Now, as far as BLE, and guys, feel free to jump in at any point on any of this. One of the big shticks about BLE in general, and this is where my brain starts kind of getting a little confused because they call it Bluetooth low energy, and they talk about having ultra low power consumption, yet it has the highest power rating of all the different classes, dramatically so. So I don't understand that kind of oxymoronic naming of this, because we're calling it low energy, but of all the four classes, it by far kicks out dramatically more power. Really, I think it boils down to the actual processing of everything on the back end. Now, as far as range of communication, typically what you see out in the wild is deployments of anywhere from 10 to 50 meters indoors, and up to about, maybe if you're lucky, depending on the environment, 100 to 150 meters outdoor. But getting that depends on the environment, right? That's going to depend on what the RF landscape's looking like. If you have any interference, if you have unshielded drives, solar flares, for God's sakes. I mean, it's 2.4, right? So all of this operates in the 2.4 ISM bands. So anything that you're susceptible to in standard 802.11 in those channels, you can be susceptible to in any sort of Bluetooth environment. However, that is one of the things that makes Bluetooth so useful, is because how the standard dictates its communication, right? Because we're looking at frequency hopping. And frequency hopping has long been known to give you a very robust communication. Now, granted, frequency hopping can, if there is a lot of frequency hopping traffic, actually cause interference in 802.11 in those frequencies. I, for one, haven't really seen Bluetooth being that dense that it causes that. However, it is in the same frequency space, so anything is possible in the grand scheme of things. The other really big deals with BLE is it enables like a quick discovery and connection, which can be in ideal situations as low as 6 milliseconds, which is a lot faster of association time versus the other classes of Bluetooth. And that's a pretty big deal, because especially if you're dealing with mobile devices, you want to keep that device-to-device discovery and association time as low as possible. And in the industrial manufacturing environment, that's even more so important, especially depending upon the use cases, where you need any sort of transition time to be as low as humanly possible in order for the controls to work properly.
Scott, I could see too. We see a lot of stuff like automotive's a good example, where something like a skillet system, the skillet comes off the bus bar, it's powered off, gets fed onto a conveyor, and then it gets fed onto something else. So when it powers back up, that gets you reconnected faster too.
No, I totally get that. Now, the one restriction, and I actually, and it makes total sense, and I don't know why I didn't pay more attention to this before, but your actual client limit in BLE is 7 clients. Is it 7 clients, Tobias? 7 clients to a single master? Is that the limit on that? Or is it 6 clients to a single master?
Currently, it is 1 master and 7 clients. Yeah.
7 clients. So
exactly,
per master, you can't have 200 nodes, but that doesn't mean you can't have multiple masters out there. If everything is configured properly, they should play pretty well together, because they're specifically going to try to dance around each other and not eat up the same channel space at the same time.
Yeah, exactly. Due to the advanced frequency hopping we're talking about in a minute, probably, we can actually, where the largest installation we have is about 100 devices in one room, in one facility, and they still work pretty well together. And usually you don't need this type of communication, because the roaming is pretty slow, actually, roaming from one access point or master to another one. So usually we do installations that you temporarily connect a client to a master for certain environments, like moving a robot, for instance, or moving a conveyor or dolly if an HV comes close, or establishing a link for safety. actually. We do this just for a couple of minutes and decouple it in the most environments. Other environments, if we have line of sight, we can easily achieve more than 150 meters indoors and outdoors. So the first, fun fact, the first spectrum analysis or site survey actually I did, I ended up in the parking lot because I couldn't trust my measurement. And I called the vendors and they were like, no, everything is fine. You just have reached the maximum. So when you're out of the parking lot or out at the parking lot. So Bluetooth is a beast when it comes to that, to the distances and the interoperability with other devices, and especially with other Bluetooth devices. So just about exactly 1 week ago, I was in an Airbus flying into the United States, and everyone has their Bluetooth headsets on. About I don't know, approximately 250 people. And let's say half of them has Bluetooth devices, so it's 125 people. And actually, I could listen to my own movie I was watching. So it is possible to coexist next to each other.
Yeah, I never really thought about it that way, but on airplanes, I mean, that's a really tight enclosed environment, and everybody is using headsets or different accessories all at the same time in a confined space, and it doesn't seem to be any issues. So that's pretty crazy. But you said something that caught my attention, and I guess I needed to think about it in a different perspective. So you're saying roaming time from a BLE client to a BLE master is actually fairly slow.
Mhm.
When you say fairly slow, what do you consider fairly slow?
Multiple seconds actually, because there's no specification for roaming in Bluetooth. It is nothing like we know from IEEE Wi-Fi for any IEEE Wi-Fi, where we do the handshakes and do all the stuff to connect from one access point to another access point. They are just not existing in that Bluetooth environment. So what we have to do is we're losing connection, and then we have to search for another one, and then we have to do all the pairing and handshake and all the stuff again, because it's not designed like that. You don't have a headset and you're roaming between two different iPhones. It will not happen. You will stick to that iPhone as long as you can. And even if you're losing connection, you're still trying to connect to that one again and again and again. So therefore, there are no actual roaming specifications in the Bluetooth spec or stack, and therefore it will, need several seconds. We can trigger it, like location-based trigger. If you have an AGV and say, okay, at this certain point in the facility, you have to decouple, you have to recouple, but this one takes longer. If you have that initially decoupling, coupling, yes, then it's pretty fast. But the process itself, it takes a little longer because the advertisement channels are also a little bit occupied, right? Because everyone is using them. We only have 3 channels, right? Even though they're spread apart, but there can be interferences, not like in the regular communication. If the communication is established, we are jumping in BLE 133 times back and forth through those 2 megahertz wide channels, which is still slow. In Bluetooth Classic, it was about 1600 times a second in 1 megahertz wide channels. But due to the different amount of frequency hopping, different type of frequency hopping, we just, quote unquote, just do it 133 times a second. And after that, we are very resilient against interferences. But that first initializing the handshake over the advertisement channel, yes, it takes a little while.
Hey, I learn something new every time. Every time we do a show, I learn more and more new stuff. But so when you look at the design of BLE, that coming into the new environment and doing that association is supposed to be super fast. If they're the specifications listing a max of 6 milliseconds. So you're saying device comes in, connects up and parks, because it's not roaming around and it's not changing. That should be super fast versus trying to roam from master to master.
Yeah, if it's starting up, it's pretty fast, but you wouldn't see it. I mean, the host system and everything else needs to boot up before that initially Bluetooth connection will actually established. So, yes, probably the specification gives us 100 millisecond, but everything else booting up and even charging the capacitors of our radios probably take longer than that. I don't know. So therefore, you can't measure that really well.
Well, this is the difference between learning via the standard versus actually deploying it and out in the field, and that's kind of a knowledge gap because I've never personally deployed a BLE project like that, so I don't have any hands-on with that sort of real world association for these devices.
Not yet.
Not yet. Well, yeah, that's true. Not yet, because I will get my chance. I'm sure I will.
I'm trying right now. I've got an idea.
Otherwise, it's Bluetooth. It does max out data transmission rates. What, at a meg or is it 2 meg? What is the max for BLE?
Again, it's very theoretically 2 megabit. It should be. I always tell my clients to not exceed or not expect more than 1.5, actually, because again, we could write on that 1.21 giga watt, but it's actually just 100 milliwatt. So we try to be more realistic. There are different modulations actually in Bluetooth itself. Our radius has 2 different modulations officially. Which one is going to 2 megabits, the other one is officially 1 megabit. But due to the modulation, we can actually almost double the range between the client and the master, because modulation can be a beast, right? I mean, if you modulate very strong, very hard, you're losing the throughput, but you're gaining a lot of resilience and for the distances and all. So officially, I would say 1.5. If someone would just call me right now and ask me,
I would completely agree. When I was running throughput tests on the pair of Data Eagles you loaned me, that's what I was consistently getting. I probably 20 separate consecutive tests. I was pretty much right on that mark every time, just trying to load test this thing and just max out what I could push through it. At first I was just kind of using JPerf, which is iPerf with a nice little GUI interface. And then I was like, screw it, let's run some, let's go to speedtest.net, right? And so I was just pushing a speedtest.net run through it. And again, maxing out 1.5. That was just but it was consistent every single time. There was really no variance to it. So what that tells me is it's a really solid protocol build. It's very predictable.
Yeah, that's actually one of the biggest advantages for me. It's far away from being deterministic or anything, but you can rely on it. So in Wi-Fi, I mean, as we all know here, the further you get away between the access point and the client, the slower not sorry, the slower the slower the communication actually gets. So
The lower the data rate.
No data rate. Thank you. The lower the data rate is, you're ending up with a couple of megabit, while officially on the print on the packet it states 1.93 gigabit per second or something. But again, it's a laboratory environment, and if you're just increasing the range or the distance, everything goes pretty down pretty fast. In Bluetooth, as long as you are above a certain line, let's say let's max it out, let's say minus 104 dB, you're still good. Everything below, it's absolutely far away from good, but you have that very strict white and black. There's very small gray in that working. So the same with the data throughput. It works. If it works, 1.5 megabit. It's not working, close to nothing.
So you're saying a noise floor as low as 104? Is that what you're saying?
Theoretical, yeah. That was to max it out. Let's start with minus 90. Minus 90 is minus 90, minus 90, 95. But it is, comparing to Wi-Fi, it's definitely way more sensitive.
From what I have tested with these things in the lab, I completely agree. Very, very robust. So one of the big things about, and this is where I always get myself in trouble, is yes, Bluetooth is frequency hopping, and I have a bad habit of when I'm explaining frequency hopping to somebody, my brain immediately goes to standard FHSS, frequency hopping spread spectrum, or DSSS, direct sequence spread spectrum. because it's so much easier to explain those concepts to people who are less technical. And then I catch myself, that's what I say here, that's what I say there. And I know in the past I've talked about Bluetooth, and I know in the past it's frequency hopping, spread spectrum, and I just, because it's the first thing that rolls out of my mouth, because I'm so used to having to explain it to people who aren't as well read on a lot of these protocols and how they transmit. For reals, on what it actually uses is AFH, which is adaptive frequency hopping, which is a different animal, right? And apparently there's a couple algorithm variants of these. You have the original specification, which they refer to as CSA1 or Algorithm 1. And it was like I said, it was introduced with the original BLE specification. And it's using like a very simple, very straightforward incremental approach to select the next channel. It's a uniform process. It's very deterministic. There is no randomization, so you can predict it. You know what's going to happen. You know where it's going to jump to. And that was primarily used in the earlier versions of BLE. Now, when BLE hit revision 5.0, that changed. And that's where they moved into CSA2 or algorithm number 2. And this is where it becomes even more robust, because it gets in there and it uses this pseudo random sequence in order to hop channels. And that pseudo random sequence is coordinated on your 3 coordination channels, which in BLE is 37, 38, 39, right? And those channels are non-congruent, meaning even though they're numerically listed as congruent, where they actually land in the spectrum is not congruent, because like one's all the way to the left, one's all the way to the right, and one's off center of the center, and so it's 3 different chunks of our areas within the 2.4 spectrum. So if one gets overloaded or blacked out for some reason due to interference or other traffic, it still has the other 2 to rely on, right? But it's that pseudo randomness that really gives BLE 5.0 and above such more resilience to interference in general. And good luck trying to capture that traffic. Just in general, because it's one thing if it's deterministic and you know where that starting point is, you can calculate and then you can follow the pattern and you can capture the traffic, right? When you have this pseudo random sequence, I don't see that being as a possibility realistically. In the grand scheme of things, I think if you're trying to capture Bluetooth traffic like that, you have way too much free time on your hands. But I guess anything is possible. But I do believe the later versions of AFH make that a lot more difficult, while just enhancing the robustness of the protocol in general. Robustness, is that a word? Robustness.
Yeah, I think so.
Robustivity.
Yeah, as a German, I allowed.
Well, you ask Jeremy. I like to make up words.
Robustification.
Robustification. Thank you.
Yeah. So,
Well, wouldn't it in German? Wouldn't it be like 5 words smashed together?
And very angrily at that.
Robustheit. Nah, it's just a word. Sorry. But yeah, the biggest difference between FSHH and the AFH probably is because the regular frequency hopping spectrum. I mean, it was invented in, correct me if I'm wrong, 1942, I think. The first time 88 channels to control torpedoes against German U-boats. We therefore, I digged a little bit into that history of that. And then it was forgotten until the Cuba crisis, actually, and the U.S. Navy was using it again to jumping back and forth in frequencies to make it very hard to intercept radio communication between the blockage, between the ships of the blockage, and to make it very hard to actually jam those signals. But it's just sending the same amount of data every time it's hopping to the next channel. The adaptive form on the other side, which is the advanced frequency hopping or adaptive frequency hopping, is that it's knowing, because of the map, which channel is good and which channel is bad. Super bad channels probably will be blocked, while good channels probably will be used more. Why not? If they're good, why shouldn't I use it? And this is constantly adjusted, in my understanding at least. But it is something you could, I mean, people are writing PhDs about it. So it is a rabbit hole as it's, yeah, to the center of Earth and back. But this is my understanding of those differences.
I've actually been looking at going back to school for a PhD in underwater Bluetooth weaving.
Okay.
Tobias, you might not get that, but that's like a joke about underwater basket weaving. Is like a major that everybody used to joke about a lot.
The best part is you got to explain that.
I can hear my spouse rolling her eyes right now.
BLE versus standard Bluetooth, you're looking at 40 channels versus 79 channels. So you have more channel width to work with, which obviously is why you get more data throughput versus Bluetooth Classic. Yeah. With 2 megahertz wide channels versus a single megahertz wide channel, And then again, you've got those 3 channels for advertising, right? Your channels 37, 38, 39. Now, one of the things you just touched on, and you were talking about, being able to avoid channels that are bad. That is what they refer to as blacklisting. So they will automatically blacklist channels, but they do go back, according to the standard, go back and periodically test those to see if they're viable to kick back into the frequency. Their pseudo random hopping structure. So it's interesting how all that works. It's all dynamic and it's all so fast that it's really hard to fathom it, as a human being able to really comprehend that kind of speed that this stuff is actually going through all this at. But one of the really big things that I kind of wanted to harp on here is the ranges that they talk about these really being functional at. So on episode 6, I kind of just did a deep dive based upon the standards, right? Going straight by documentation and everything that they were listing, and all the stuff that I was able to pull from Bluetooth SIG and from some other people that I talked to. And some of the ranges I thought made sense, especially when you look at power versus gear that you're allowed to use and FCC regulations and whatnot. And then, come the claims of X amount of meters, class 1 up to 100 meters, right? I can totally see that, right? Then I see claims of no, it's 250 meters outside and it's this outside, and so I was openly skeptical about that, and I believe I actually stated in there that if somebody has, if somebody is really exceeding these ranges, I want to know. I want to see it. I want to touch it, feel it, taste it. Because my brain has a hard stop on that, and it says there's no blank way that you're getting this kind of range out of this protocol at 100 milliwatts. It just doesn't make any sense. With all the long distance point to point Wi-Fi stuff I've done, and all the long distance 900 megahertz stuff I've done, it just does not compute to me that you can get that kind of distance out of spread spectrum at 100 milliwatts. But the answer to that call has been Onyx, right?
I would probably quote that.
You were at the GPA office and you were talking with a bunch of us guys at GPA. For those who don't know, that's my employer. And you were just kind of showing everybody through the demo kits and all the different use cases and being able to run it for SIP and Profi and various industrial protocols and whatnot. And then you said something that triggered the millennial in me, right? I felt triggered. It was a microaggression. I had to go and find my safe space. And you were saying that you had a deployment or several that were well over 500 meters and everything was working instantaneously. And I would love to hear you expand on that. Now, I understand if it's client-based stuff, there's only, you have to whitewash certain things, but I really want to understand how this is possible, being that I have that kind of hard stop in my brain for something like that.
Okay. So half a step back, as I mentioned, we are not the vendor of those clients. So some of the projects are done by other companies in Europe or Asia. So it's not everything I have done, but it is using the exactly same hardware and the same SKU we can order in the United States. That said, if we look at the dB or dBm, what we can actually pull out of those radios with 100 milliwatt, because 100 milliwatt will just be spread over 2 megahertz. If we do 1,000 milliwatt over at least 20 megahertz, which would be exactly the same dBm power. So the wider the channels are, right? So 320 megahertz wider channels with 1,000 milliwatt would be, let's say, a very dull knife. But if you're using the same power on a very narrow megahertz band or channel, it is pretty aggressive and pretty strong. So imagine you have the same power with a Bluetooth device. Just imagine that for a second. The same power on a Bluetooth device as you have at a regular radio running 1,000 milliwatt or 1 watt with 20 megahertz wide channel. And now what we've done is we just put directed antennas to it. And the directed antennas gains are the regular ones, the IP20 ones are 8 dBm gain up to 13 actually. And if we're using directed antenna with an angle of 33 degrees, which needs to be very accurate, yes, we can achieve a couple of installations as long as 945 meters, which is approximately 3,100 feet. And this one is running in New York City, United States, the cable car to Roosevelt Island, for instance. So imagine how much noise or radio spectrum noise there is in New York City. And it's still working because of the Bluetooth. And it's directed antenna, but we did not exceed any FCC. The radios can only produce 1,000 milliwatts, those chips. But as we all know, at least in this round, that a directed antenna is just like, I like to explain it like a torch, like a flashlight. The LED, the brightening of the LED will not change if you focus the mirror in front of it. So either it's very wide or it's very narrow beam, but the LED light will not change its brightness. And this is what we're doing with the directed antennas. The other one is in Paris, Montmartre. This is also a people mover, going up and down hill for I would say 10 to 12 years. The one in New York City is 14 years. Then there's an installation in Germany, also people mover, also downtown in the largest city in Germany, since 15 plus years. Also, again, with a lot of noise and traffic. But this is the ranges we can achieve. We have one installation in the United States, which is on an ore mining or dock crane, which is just moving one-dimensional back and forth. But we could place the antenna pretty high to exceed the Fresnel zone. And so we can just shoot with Bluetooth directed antenna a little more than 1 kilometer, actually. And it's just moving back and forth and back and forth. And that's always it's Profi safe. It needs to be Profi safe, very slow, like 304 milliseconds slow. But it's moving back and forth. And this one is working. For normal antennas, regular antennas, in a baseball stadium from the top floor from one side to another side. We did that a few months ago for an in-house trade show of a distributor. We have a flashlight set there, and we just switch on and off the flashlight on the other side of the ballpark to attract the people, and it's working. It was working for 2 days straight with one millisecond actually, 1 millisecond delay. So yeah, this is what you can achieve when you have proper antenna and do a little bit of let's say wireless assessment. Don't confuse wireless with Wi-Fi. Wireless assessment with all the spectrum, what's going good, what's being bad, and you can easily achieve that. Yes.
To give some perspective, several years ago here in Wilmington, North Carolina, is a smaller city, right? Our downtown area is maybe altogether a square mile on the river. I just did a roll through on a three going straight down the street in a 3 city block area. just to do an SSID count, just to see how many beacons I was getting. And within 3 city blocks and this is a small, air quotes here, small city, right? Nowhere near the physical size of something like New York City. I want to say we were topping out over 370 unique SSIDs over the course of 3 blocks going in a straight line down the street. And that's on street level, so higher, there could be more, there could be less. It depends, right? So if you use that as a baseline and looking at that kind of crowded environment for this area, when you look at even a major urban developed area like New York or Charlotte or Atlanta, I can only imagine it's exponentially higher. And the fact that you can literally cut through that like a knife with kind of a laser focused BLE. Really, I mean, that's what it sounds like you're doing. When you were given the explanation of the LED flashlight and the brightness of the bulb is not changing, this makes total sense to me. I really like visual explanations. And you're narrowing down the aperture. And so as you narrow down that aperture, the brightness isn't changing, but it's going further. Right. And so it's able to pierce more of the darkness, so to speak. That's really, really interesting.
But it's not only for outdoor environments. So we do that actually a lot. Obviously, we do that a lot in-house. Just been to a site survey in the United States last week in a larger paint shop, and they wanted to have access to the PLCs because they didn't want to drill a hole to the walls of those paint shops. I mean, by any reason, right? So loss of gas and the dirt and so on. And we could actually achieve 2 levels of permanent connection with our survey through the whole metal and sheet metal and everything which is in there, and glass and cars moving.
So full building penetration with all of the accoutrements that are part of that. You're getting 2 floors away.
Was regular antennas or regular bench testing antennas, as I like to call them, because they have a very low IP rating, and I like to use industrial stuff, right? IP68, IP65 stuff. And we just did a test, and the customer was like, "Okay, let's max it out." So he entered one of those painting cells with all that that overalls, coveralls, and he just placed the antenna. Okay, let's walk. So we walk. And turned out we had coverage for, I don't know, 70 meters in a bubble in a 3D environments. So yeah, sometimes it is impressive. Sometimes I'm super impressed about how far Bluetooth can go and how it's actually working with all the metal. It comes to its limitations. There were installations in the meeting room, and they closed the door and everything shuts down. I was like, what the hell is going on? And it turns out there were aluminum foil in those meeting walls. The American default walls, like the size of a toast. But inside there were aluminum foil. It was like Faraday's cage.
Yeah.
So nothing. The door was open. Everything was good. The door was closed. Everything shuts down. And I was a little bit concerned about that. But yeah, it turns out it was just about that. So yes, it has its limitations. It's not the next. You can't cure anything with it. But if you don't want to talk to IT, don't look at me bad, Jeremy. But if you don't want to talk to IT, use it, plug it in, walk away. It's working.
So the antenna you were using for those tests, that was an omnidirectional antenna, correct?
Exactly. Regular. The small one, the as big as a finger. I had
like a little dipole, single polarity, or is it a dual polarity pushing out like a globe?
No, single polarity.
Okay.
I'd like to take a moment to thank our sponsor for this episode, Global Process Automation. GPA is an engineering and technology firm based in North Carolina, serving clients in industrial processing and manufacturing, focusing on solutions for industrial automation, operational technology infrastructure, industrial control systems, cybersecurity, manufacturing intelligence, and analytics. For over 25 years, their clients have entrusted them with their processes to maximize their company's efficiency and obtain an optimal ROI based upon their assets while protecting their operational technology resources. GPA's mission is to automate, optimize, and secure manufacturing floors everywhere while maintaining their core values to have integrity, to continuously improve, embody their community, remain customer focused, and implement great teamwork. Thanks, and back to our show.
Interesting.
So, yes. So I'd like to. So that was actually the reason I reached out to you back in the days, because you said that Bluetooth has a range of maximum 100 meters. That was the first heartburn I got, and secondly about it's not reliable and fast enough for PLC traffic. And I was like, I was just leaving a factory connecting SIP safety, and I was like, what? What did he just say? So I was like, no, I have to write you an email.
But no, and I appreciate that. That was the whole point of doing the call out, because if that was truly possible, I wanted to know. But again, going by the standards and looking at that documentation, so going by that documentation, what you're talking about shouldn't be possible, right?
That's right. I mean, for the distances, maybe it is again antenna with a lot of gain, and we have to be careful with gaining, because I think you mentioned that from a donut shape to a disc shape, as long the more gain you put in those omnidirected antenna, and then a 3D omnidirected antenna becomes a 2D omnidirected antenna sooner or later.
Yeah, but when it comes to omnis, the higher the game, the narrower your horizontal plane of broadcast. So,
and the other magic, our devices, the Data Eagle. Let's give the kid a name. The Data Eagles are doing is the pre-processing. So we're not sending every Ethernet frame we're receiving. We are sending the diffs. So every time, let's assume let's say we have an Ethernet IP connection, right? Ethernet IP, it's nothing super fancy, it's nothing encrypted, nothing in it, and you're just sending back and forth temperature data, just temperature. Let's say, what is it right now here, 95.0 degrees Fahrenheit or something outside. We're just sending it constantly. Constantly means every 50 milliseconds. Why? Because let's say 20 milliseconds. Because it's default in PLCs. No one likes to touch default values whatsoever. And so it's sending every 20 milliseconds the same data, which is 95.0 degrees Fahrenheit. And so we don't send the whole packets, including destination MAC, source IP, destination IP, payload, checksum, and so on. We're just sending, in this example, just sending, oh, nothing changed. We're just sending this information, nothing changed in this particular packet from one side to another side. And the other side will just copy and forward that packet. If something is changing, let's say you're going from 95.0 to 95.1 degrees Fahrenheit, we just setting the difference, like, oh, 0.0 to 0.1. Please change that. And so the other recipient, the other side, the recipient will just change this and just forward the packet, so we can reduce the data by a lot. This is the reason we can go ridiculously fast for, I mean, the company who built that, and I didn't invent that again. I didn't invent that in my cold, wet, dark basement. The company did that actually 20 plus years ago. They started with Profibus. Profibus. I had just a project a few weeks ago. It's interesting. It's completely different from network perspective, from my perspective. But they started with Profibus, then Profinet, ProfiSafe, and then SIP safety because of Ethernet IP. They do CAN bus. They do what was the other? Modbus TCP, DeviceNet, you name it, they have it. EtherCAT application protocol, not EtherCAT itself, because EtherCAT itself is really the evil itself. But from my perspective, if you try to transmit it radio-wise. But this company is doing it for 20 plus years, and so they can be ridiculously fast in terms of Profinet, because we're just sending, oh, nothing changed, because there is nothing to change in the temperature. And even if you're just moving a little bit forward, you're just sending, oh, we moved by 5 centimeters or 5 millimeters or 5 kilometers or whatsoever. It is another thing if we're talking about safety, because in safety, and I'm more familiar with SIP safety actually, and Ethernet IP. In SIP safety, you have a connection ID and you have a sequence number. So every time a user, or let's say a master and a client, it's a pops up thing between two PLCs, for instance, has a connection ID. You're just assuming a random connection ID, and then you have sequence number, which counting from 0 to infinity theoretically. Every time you're sending a package. This is the payload. You take this payload, invert the whole payload, put a CRC checksum behind it, and this is your frame. And you can't know it because it's so scrambled. Every time you're sending a packet, obviously the whole payload between the starter frame with all that stuff, the known stuff like source and destination, to including the CRC checksum, because it's IP, right, layer 3 based, you have to transmit it. Therefore, we cannot be that ridiculously fast. We just can go to 25, 30 milliseconds instead of 1. And that's the only downside. But it is what it is, and you have to you can't beat physics.
So you touched on a couple things that I just want to backtrack for a second. For our wireless people who are not versed in the industrial universe, SIP is actually CIP, that's Common Industrial Protocol, and then it has a safety mechanism that is referred to as SIP safety. Ethernet IP is Rockwell's industrial protocol that is wrapped in an Ethernet protocol, an Ethernet packet for Ethernet transport, so it doesn't have to go over solid core copper. You mentioned Profibus, that is Siemens Industrial Communications Protocol, and then Profinet, which is Profibus that is just flipped around, wrapped up in an Ethernet container and kicked across the network, right? So for our non-OT guys, that's what we're talking about here. These are industrial protocols that were then adapted for transport across Ethernet, which is what allows us to work this wireless magic because we can make it transparent, right? For the most part.
Yeah, exactly. Especially Profinet and Profisafe, but they are skipping a lot of layers. Actually, it's just layer 1 to 7. There's nothing in between. You don't have IP. You can't route it. It's you need 100% transparency in your radios. Otherwise, you won't establish a connection because you need an IP address for regular radios. So therefore, you need to have special stuff. But yeah, I think this is the biggest difference between commercial, enterprise, and industrial wireless or environments itself, because you're handling protocols which no one actually heard before. I mean, SIP safety or EtherCAT or no one uses it. I mean, commercial, it needs to be nice and cheap, and you have to be fast and download stuff. Enterprise, probably large amount of people. I'm still impressed if people say, "Oh yeah, we do the soldier field in Chicago with 110,000 people, and everyone has wireless access." Like, what? That's impressive. But we as industrial guys, it is more like not losing a packet, because if you're losing too many packets in a row, the robot will stop working.
It becomes detrimental to the process, right?
Exactly. So
one of the big things that I use as an example that I use to tell people the differences between OT and IT is when you go and you look at the standard CIA triad, right? That you learn in IT class 101. You know, it's they give you this pyramid, and it's CIA, right? And it's confidentiality, integrity, and availability, right? So confidentiality, security is top dog, right? And then data integrity, and then availability, right? So if it's not available, you know, if you get some lag and Sally from accounting can't watch her cat video, who cares, right? But it's a different story in the OT universe, right? So we flip that triangle, and availability is our top dog. And then second up is data integrity. It has to be available. It has to be complete, right? It's got to get there fast, and all of it has to get there. Security, well, that's kind of a nice to have. That's a bolt on after the fact, because if security is going to interfere with, if the C is going to interfere with the A or the I, then C's got to go, because getting complete data reliably is so much more important in the OT universe than having it secure in the grand scheme of things. Because whether it's secure or not is not going to stop the process, but not having it available or not having it complete will stop the process every time. So, it's a complete different mindset and philosophy based, operational, for these environments.
Yeah, and don't forget about the turnover. I mean, 2 seconds of downtime in a Teams call and this Zoom call probably is bad, and people won't like it. If it happens too often, we get emails and someone is complaining. 2 seconds cost about 500, let's say 500 to $2,000 turnover for an automotive. And if you need to shut down and someone has to run there and reset the fault and restart the GA trim line or something, you're losing 60 seconds. Or let's say you're losing 5 minutes, and every second is about $400, $400 in turnover. So this is a very different game from
Well, and then
enterprise.
on top of that, you have the hidden costs of lost productivity.
Yeah.
You're not paying for the people who are doing that stuff because you're not generating revenue in that time span. So, and then God forbid an incident happens and you have massive downtime, because then there could be safety issues as far as the human risk element. And then there's the unforeseen risk of damage to reputation and insurance costs and different things like that all of a sudden go up. So it's a snowball effect that general access Wi-Fi for enterprise does not have, right?
I think too, just going back to the, like an automotive line or something like that, they're expecting to send a car out every, what is it, like 2 minutes or 5 minutes, or and that's a lot of money. But then there's also there's some processes that we see sometimes, and it's like, if you stop it at all, you might have $500,000 roll of some, high end, forget what the term for it is, but there's like very persnickety kinds of things, and it's like, if you stop that, they have to, they just have to scrap that whole thing. Cathode, that's what it was, and some of those kinds of things. Yeah, but it's incredibly costly. And don't get me started on security, Scott, because Lord knows, flip over a keyboard.
Well, and to take this, what your example just kind of a step further, is any sort of chemically controlled reaction. You disrupt that. Once that reaction started, it's not like you can just put the brakes and stop that reaction. So there's a like I said, philosophically, there is a completely different operational mindset for OT versus IT. And once you wrap your head around that, and take that on as a perspective, things make a lot more sense, and you start really understanding. And that's what I think, to kind of bring this back around, is what makes the reliability of BLE for these types of deployments so impressive. Because for years and years and years, when you go and talk to your operators on the floor, or your E&I guys and your electrician, and you even mention wireless, they'll throw you off site, because it had such a bad reputation for reliability. But over the past 10 years, it has really come to light that that is not the case. Granted, it has to be purpose built, purpose designed, purpose deployed. You're not going to just be able to throw out any random 802.11 and expect that kind of resiliency out of, right? It's got to be a purpose-built protocol. It's got to be a purpose-built deployment. It's got to be planned very well. And if you're using the right protocols with it, and then you have the proper design, you've done all the legwork, you can come out with a solid wireless deployment, not 802.11, but wireless deployment that will accomplish the goals within the parameters that you need it, that will keep you productive. End rant.
Mic drop, yeah.
So what we go through all of this, and we talk about, just how amazing AFH is as far as an algorithm, and we kind of touched on how 5.0 is so much better than the previous renditions of BLE, and channel assignments and all that stuff, and dodging around. But realistically, when it comes to Onyx, when you're getting these crazy ranges, we kind of talked a lot about that, and that's really having to do with antennas and proper design and things of that nature. Do you guys use any sort of proprietary software, or do you have like a low level chip access that you're able to better control that from a chip level versus a software level? How are you guys able to kind of work your marshmallow magic without giving away anything too crazy?
That's the best part. I can't give anything too crazy away because there is actually not that much crazy thing. The radios are class one Bluetooth BLE radios. It is the pre-processing in the microcontroller who is reducing the traffic, and that's the magic. That's the one. That's the license which is costing cost some money, but the rest is regular Bluetooth straightforward. There are probably some ideas to tweak on Bluetooth a little bit. There are companies who have access to those chips and try to tweak and to squeeze more data in or to make it a little bit faster, more reliable, and so on and so on. Use different modulations, but the products we have is regular default Bluetooth. Talking about default Bluetooth, and I'd like to highlight that in terms of cybersecurity, the Bluetooth comes with a default 128 AES encryption, right? So if you do not trust our encryption or not trust our key, you have there's a Windows software and it's called Wizard. You plug it in with your with a USB cable. You can change that passphrase if you want to. So if you don't trust ours, be my guest and change it. But if you forget it, you have to redo every device in that paired set. But you could do everything you want with those with this wizard. So in terms of if someone hits it with a forklift, for instance, or it burns down, or you put 110 volts to it or something like that, then you just have to plug in the USB cable to the other one and just change the MAC address, and you're good to go for the spare part. So it's nothing we are hiding. It is straightforward. It is Bluetooth. It is just the pre-processing to be written very exact around those industrial protocols and safety specifications. That's it. It is written down in all those specifications like ODVA or Profinet that you can use the black channel approach. You can use my words here. You can use whatever you want. It can be copper, fiber, or over the air. Because if you cut the copper or fiber cable, it will stop. That's the safety stuff, right? If the radio link will break, it would stop. So that there's no magic inside. We don't have a CO3 or PLE certification because we are just fast enough and reliable enough to actually transmit it. That's it. Period. Straightforward. It's no black magic.
That's impressive seeing a product that is literally using it by the book with no added other secret sauce to try to manipulate it and make it and or better when you're already exceeding what they're saying you could do and you're not modifying it. You're not doing anything proprietary to it. That's pretty cool.
No, not yet. If there will be a version, I will let you know. But as of now, it's straightforward.
So that all that being said, what else do you guys have out there on the market on top of the Bluetooth that we've been talking about ad nauseum for the past hour?
Okay. Brace yourself. Sorry. So let's start from the spectrum on the left-hand side. We have 900 megahertz radios, as I said. So in general, the Data Eagle, we have 2.4, which is Bluetooth, or 900 megahertz for longer distances. It's not we don't like to do safety over it because it's way slower. You can do it, and there are installations, but they are very specific, and we have to tweak a little bit here and there to make it work. But for mining, for IOs, for stuff like that. The Data Eagle itself can not only do PLC to PLC or PLC to remote IO/point IO, but also for we have remote IOs. So what we do is the stuff in, stuff out device. We have two IO blocks. One is the input, one is the output. You just have the input without any PLC, and we just transmit it over the air via Bluetooth to the output device. We have that in IP67 rated, which is limited on the range because it's internal antenna, or we have that in IP20. Probably want to house that, but we can achieve the same distances because it's the same Bluetooth device, right? It's our default Bluetooth device. This is what we can achieve. Then we have Wi-Fi clients. Jeremy, look in your direction. You still have one of those guys? I
Yep,
think this
I've got one
6.
sitting here, and we've got a couple of customers that are deploying them on AGVs.
Yeah. Do you have 4 the Wi-Fi 4 or Wi-Fi 6E? What is it
This
right
is
now?
the one that I have, our test units, the 6E.
We have 4 and 6E as of now. And this is regular Wi-Fi, and this is, I don't want to call it boring compared to Bluetooth. Don't get me wrong, I like Wi-Fi. But we have some nice features on those Wi-Fi clients. We have RS-232 converters inside those devices, so you can actually plug in DB9 plug with serial, and it translates instantly to TCP/IP traffic, for instance.
Yeah, you've got like on those clients, you have a handful of different kind of what's the word? You have like a variety of them that support like that RS-232 or with or without those ports, right? I know there's several models, so it's kind of, you can kind of customize it a little, or not customize, but you can kind of purpose order for what your application is.
Exactly. The others like RS2, what is it, 485 and all the other stuff, we could do too. The feature I like the most, and actually this is the reason why the people are buying the stuff mostly, is not because it's so reliable and good, and you can do all the stuff on WPA3, all certificate rollout, everything, you name it, we have it, but it has a relay. So you could send a UDP or TCP or even an MQTT message to that device, and it just shuts off or on the relay. Imagine you have a 550 AGV large fleet, and every Wednesday evening before Thanksgiving, you have to have 5 engineers running around, shutting every AGV down, wait until it stopped, and so on. With those radios, you just go to the HMI, type in the super user, send the signal, 550 AGVs shut down. You could see them actually leaving it because only the radio will stay awake and all the PLC will shut down, which we could actually track. And on Monday morning, if shift starts at 6, you don't have to be there at 3 with 5 people running around and starting the AGVs. You just have one guy, super user password, start 550 AGVs running around one time to approve that the weight, the position, everything is still there. This is what I like. We have infrastructure for wireless solutions, which is nice because they don't have any controllers, any license. You just program it, you plug it in. If it breaks, you pull it out, take a new one out of the box, put the backup in, both. It's good. I don't like licensing from other companies. While it's you break your fingers when you try to pull off a license from access point, which just burned down to ashes. I don't like that. So we all know
You've got to email somebody, and then you get the out of office email and email this other person, and then they don't reply to you for 3 or 4 days. I've seen that.
Yep, we've all been there, yeah. So we decided
And
to go.
I'll say this. This is not a paid commentary, but the kind of, I mean, even before speaking to you, we ran into some of these on devices without, going in cold. And it was actually like one of my newer engineers that I work with, and he was able to get in and do all sorts of stuff with it without really having ever touched it before. Configuration changes. We got him because you have a configurator software package, right? For that, and it's very like user friendly in that way, and you have logging that is very nice.
Oh, on the clients, the logging is actually so good that I built my own site server tool with that, because logging is so deep and it gives you everything you need, and you can tweak every channel, everything, and you can plug in the USB port and just let it run piggybacked, battery powered, when you piggyback on the AGV, and after that you get to collect the data with a timestamp, and then you correlate that with the PLC data of the location. So what time did what AGV at what location, and what are the measurements? And so you can build your own heat map in one round, and without any expensive tools, and actually everything you need. So I like that one. Yeah.
Do you have do you support like webhooks and various APIs so you can like customize and create your own kind of monitoring dashboard or sequences?
No. It's the raw data, and you have to build that on your own. So you just get the raw data, but including every wireless header you want and you need. So that
Are
is
you
really
able to? I don't remember off the top of my head. Are you able to export it off of the vehicle? Or like
Yes.
off, excuse me, off of the client, like you could send that off of there too.
Yeah. So you have three different storage options. One is the RAM, which is if it shuts down, everything is gone, but it's mostly okay. Then there's a flash. Don't do it too long. Don't do it too often. It's a flash. Sooner or later it breaks. And then there's using USB. So just plug in a USB device. Don't ask me about the file format. It needs to have X3 or something. And then you can just select this one as your folder. And I think the biggest one is 128 gigabyte. It will last a long time until it's full.
So you just go get a little flash drive and plug a flash drive into it and roll with it.
I never tried that, but probably yeah, why not?
Wait, that's what we did. Just
okay.
Just
okay. Well, there you go.
driving it.
Okay. Yeah, that's for the client. Again, we do a lot of testing and measurement and so on with those guys, and it's really good.
Hold on.
For
Let me
Yes,
clarify. It was an industrial rated USB flash drive.
Did you plug it into the USB cleanser box before you actually used it?
It was not a USB from like a Walmart or Best Buy.
Radio Shack.
Oh,
I spent some time in Radio Shack back
Same.
in the day.
Back in the days.
so for standard industrial Wi-Fi clients, when you're looking at a per radio per bot scenario, the $1 million question then is what do roam times look like? Because that's what everybody asks, right? That's what everybody wants to know. How fast are you roaming, right?
Yeah, that's
I'll
not
be that guy. I'll throw it out there.
question.
I'm not scared.
Okay, so the regular, so our regular client, with all the nice features we just talked about, and our regular infrastructure, which is not the client, we have another infrastructure, without the license and everything. And if it breaks, you put a new one in and all that stuff. But it comes with the software to manage everything, but you don't have to. The regular flash time, roaming time is about 20 to 32 milliseconds. This is mostly okay. This is third party.
So that's connecting up to a third-party infrastructure, not your infrastructure.
That is our infrastructure, but the infrastructure is from vendor A and the client is from vendor B. So they're not familiar with each other, but that roaming time is between 20 and 32 milliseconds right now.
Okay.
This is mostly actually okay. I mean, talking about Ethernet IP. If you want to be faster than that, the access point from vendor B I just mentioned can be used as an access point or as a client, or actually as a VWS, a WDS, wireless distribution system bridge, right? So if you're using the same client and infrastructure from the same vendor, there's a feature in it. It's called, they call it flash roaming. It's their name for it. And they can go less than 5 milliseconds in 5 gigahertz network.
So that's an Onyx base with an Onyx client.
Exactly. Onyx to Onyx infrastructure, and then modified as a client, less than 5 milliseconds. This is pretty incredible. We do not have that much features though, as we have on our regular clients with all the relay and all the stuff we just mentioned. But if you just need a regular one, and we can do Profinet transparency. We just talked about the Profinet transparency
with that same roaming time and stuff. Man,
yes,
that's incredible.
It is.
That's some overhead crane system.
Yeah.
That would be pretty useful. That'd be worth testing out.
Yeah, say the word. We have so many of them.
Well, I mean, if anybody out there is listening and wondering, they're having problems with something, that definitely would be worth slapping a couple of those in there and trying it out.
Yeah, that's really impressive.
The good thing is that you can't, not naming any other vendors, but then IT can't really like throw that in their overhead something center and then start making changes to it.
Yeah, but it would be a pretty tough fight against IT to say, hey, we would like to have our own shadow infrastructure for wireless. Please, I'd like to have this and that amount of channel for my roaming. This will be pretty bad. But I'm used to that, so give me a call and we will do that fight. So
we'll send a crew in with some brass knuckles and deal with them. So you said Profinet transparent. So these will carry like industrial protocols over there. Have you done any like SIP stuff over those?
No, SIP we have not. But I probably will test that out. But I didn't have any reason because usually for SIP we use Bluetooth or our regular devices, because for everyone listening, SIP and Ethernet IP is layer 3 and above. So it actually has for any communication an IP address, which is mandatory for regular Wi-Fi for our regular client. But if it comes to Profinet, they don't have IP addresses, so they need to have that special source in those access points and clients. So I didn't have any reason to do it yet. I actually have got a new firmware, and I'm up in Michigan in our office, in our lab next week. Right now I'm somewhere in Pennsylvania, and I will definitely test new firmware out. And why not? I have PLCs with me, and I could give you a shout end of next week and tell you if it's working or not.
And then what's in your 900 megahertz radios? What protocol do you have those? What is that kind of based around?
Protocols in terms of industrial protocols, or
are you using, are they like are they like Halo radios, or are you doing like LoRa, or is it kind of
a regular 900 megahertz ISM band? There's no IEEE beyond it. It's sadly not Halo. I'm pushing the developers to do a little Halo because I'm a big fan of Halo, but
You're just doing kind of in-house data protocol for 900 megahertz.
Yes, it's proprietary between those. So we translating, for instance, for Ethernet IP, let's say temperature, right, or filling sensor, Ethernet IP, then magic Bluetooth, and then again Ethernet IP both to the PLC.
So on the 900 megahertz, what kind of channel space are you eating up?
Very narrow channels. We are consuming. We are able to do every channel in 900 megahertz, which is, oh god, don't quote me, 901 to 928 or
902
something?
to 928 is the
902, yeah. And I think so. We do not do any frequency hopping yet. So no meshing, no frequency hopping. It is straight about the
and you're just using the 1 megahertz wide channels.
Yeah.
Okay. So you just pick your channel and that's what you're going to use. Okay. No, that's really straightforward. So
yeah, it is. It's straightforward. It's working mostly fine. So I haven't had any issues so far. Knock on wood. So yep, let's see that. Beside that, we have two more things.
Did you say something? Oh, sorry. Did you say something about you're probably about to say it, but I heard you say something about PRP earlier, and I don't remember if it was before or after recording. But
exactly.
Redundancy is that's always a good topic.
Exactly. So two more things we are looking into right now. It's a little bit sneak preview. One might be something in terms of RTLS, because it's network based and it is radiating, right? So companies approach us like, hey, you guys can do that. We're like, yeah, sure, why not? It's a little bit more Kubernetes, a little bit more Hyper-V, a little bit more firewall, but in general, it is network. So yeah, we could do that. So bear with me. Check our website from time to time, because there will be probably something with the RTLS in the next few months. Let's see. The other big thing is something between the Bluetooth and the Wi-Fi, or let's say that's a triangle: Bluetooth, Wi-Fi, and the third one would be as of now proprietary stack used on top of IEEE. So following IEEE, not like Cisco Curve, no offense, but you can actually see it in your regular oh, you should see both.
That's it. I'm out of here.
So yeah, you can actually see them with a regular Wireshark because it's IEEE, but they have multi-radios on access point in clients. So they're doing PRP between 2.4, 5, or 6 gigahertz, which I really like. And you don't have to you're not avoiding CE, FCC, or anything, because it's regular IEEE. You're just duplicating the packet, sending it through different channels, deduplicate if both packets arrive on the other side, and that's it. That's easy. That's straightforward, right? This is what is it? Hirschman BAT 450 or something. So legacy, but those guys are synchronizing the access points on the back end via a TDMA, which means the roaming time can be less than, I never tested it, 2 milliseconds, maybe 1 millisecond. I need to test it. And I just saw the specs, and it's awesome. They're doing it in Germany and Europe.
And you said this is Hirschman that's using TDMA?
No. Back in the days, Hirschman DAT 450 was using PRP.
Oh, okay.
but
Okay.
but this was that was long ago. But right now, the new company or the new fellas are doing also something that's PRP like. Yeah, they're splitting they're duplicating the data packet transmitted over two different channels. Both can be in 2.4, both can be in 6, one can be 2.4, the other one 6, whatsoever. You can decide with a GUI, with a web GUI, very nice web GUI. And then if you if the access point, for instance, is receiving it, it's deduplicating that packet or frame and just sending it on the wire. But the real black magic is about the roaming, because they are doing triggered roaming in the access points, from my understanding. But again, I have to look into that. It's a very, very super sneak preview, and they are promising roaming times beyond our understanding, actually.
And
This
is
worth.
that the AP trigger in that, or is that like your PLC is because I know like in the newer Siemens IPCF they have. Oh God, I'm gonna sound like an idiot here because it's blanking. But you can either send like a PLC based packet or you can send like I think it's like a TCP message. But is the AP making the decision, or is it like the control system is saying, "Hey, we're at this point. This is a good time to roam," or
I can tell.
is this a that's in their cloud of magic
I,
currently?
I probably can tell you in 10 days, or
Okay.
maybe 14.
And
So I'll look
is
into
this
that.
like one piece of hardware with like multiple radios, or are they using like a redundancy box or okay.
There's one piece of hardware. Redundancy is implemented in those devices, or the redundancy radios in those devices. The access point has uh, seven antennas or something. Really, I have to look it up, but this is something I really like to look into it,
So
because when it's really
is it like
working.
a an SDR in there where they're able to kind of like split it out, or is it I got you. Okay.
I don't know. I don't know. Again,
But I
it's a
mean
sneak preview.
if you're not having to like split your packets with an additional piece of hardware, that's always good.
So
Because
let's.
that gets kind of weird because it's we've done some stuff before where it's you have to kind of watch out in wireless using like an Ethernet based PRP because the buffer that's in it, you'll get out of sequence packets, and then it causes a lot of problems if the delay in the packet is past the basically like the limits of the buffer that it has in it.
Really? Whoa, okay. Because we are doing PRP with switches for.
So if you have like if you have like a sufficient amount of so like an example would be like if I send packet number 15 and then I can my buffer's 255 and then there's some sort of latency on the second one and then I get back around and I send another packet 15 and then the first one that I sent comes in, then you get like out of sequence packets and it can cause problems.
Yes, of course. But that's interesting that that's an issue. Okay, but yeah, we do that for power plants, actually. Zero delay failover, stuff like that. So
Mhm.
PRP and switches, and I never run into issues like
Well,
that. But
you don't really see it like on a wired network, but we've seen it over like a wireless where it's like the buffer that's in them isn't sufficient to, or sometimes you'll run up, we've run up against it in some things we do.
okay, interesting.
So
Interesting.
if you're sending like a boatload of like of packets per second, you can kind of run into it sometimes.
Yeah, but that's in a nutshell what we're doing, and I'd like to highlight we do a lot of services. We because we could only sell it because I'm not a sales guy. I'm more the tech guy. Hopefully everyone recognized that. And
We typically don't
and
have sales guys in here. We usually have
yeah,
the tech guys because we don't want to talk sales. We want to talk the technology because that's kind of the whole point of the show.
so I would say we are more like a VAR. I think it's value adding reseller or something like that. But
A
we do a
VAR,
lot of
yeah.
yeah, we do a lot of site surveys and Wi-Fi assessments, and we do FAT, SAT support. So again, as I mentioned, like hey, that AGV, we piggyback a client on that. Either it's the WLAN Pi or one of our clients. We correlate the data with the PLC data of the location. We write our own small databases around it. We do a lot of troubleshooting for segment changes for any skillets or any AGVs, AMRs, if they're going from one to another, how many SIP safety packets they're losing, if the actually if the order of those SIP safety packets is correct or not, which is in roaming sometimes a little bit weird, stuff like that. This is what we're doing, and this is what I'm doing actually for the last almost 5 years now, looking into Ethernet IP and SIP safety packets more or less weekly from the use cases for Bluetooth. We do a lot of IoT lately. This is weird because I left IoT a few years ago, and now everyone is coming back because no one wants to run a wire or cable anymore. So they do, well, let's do Bluetooth.
Honestly, this goes back to the reliability discussion we had that originally, industrial guys, if you even mentioned wireless, would throw you off the site. But now that they understand that the reliability is there, IoT made its first big push, and then and that's when the IIoT phrase got coined, right? And then you didn't hear anything for a while, and now it's on another big push back in because. And only the difference is it's not the outside trying to push it in, it's the inside asking for it. So it's a different scenario than it was 5 years ago. So it's not the sales force trying to push it in. You got to have these, you need these, you got to have these. Now it's okay, this technology's proven itself. We have the budget, but we don't have the budget to run all this copper or run all this fiber, but we really need these sensors. And we now know and understand and can trust the fact that we can get that data reliably over wireless. So now let's ask for it. It's kind of like anything. If you have too many people trying to shove something down your throat, eventually you're going to be like, I don't want anything to do with it. Get it out of my face. But when it comes to the point where the understanding is there and they get it and they're saying, oh, well, you know what? This is what we need. This is a solution we can trust. It's proven itself. Let's ask for it. And now more and more sites, or at least it's been my experience in the world of pulp and paper and the world of discrete manufacturing, obviously not including like car manufacturing, because those guys are like bleeding edge way ahead of their time. But in the realms of dirty manufacturing, which is where I live, which, their rate of change is very, very slow and I literally say this probably every show. Dirty manufacturing is probably a good 10 years behind modern technology versus enterprise, which tries to stay pretty much not necessarily on the bleeding edge, but at least right there on the cusp on every refresh cycle. And then also too, in most of these places, their refresh cycle, if it even exists, is more along the lines of a 10-year cycle. You're not going to see it on a 4-year obsolescence cycle. It's just not going to happen because they're not going to shut down their stuff for long enough for you to go through and replace all that.
Absolutely. I mean, it was on one of the earliest Heavy Wi-Fi, I think Heavy Wi-Fi podcast, when it said, okay, first it's always consumer, then enterprise, then industrial. And I'm replacing Profibus connections actually with our wireless solutions, and mostly in steel mills and stuff like that. Because again, they are maybe more than 10 years behind.
And how many years has Profibus been out there? Quite literally.
No idea.
40 years?
I have no idea really.
Well, you said that was it RS485 connector earlier that you have on some of your clients. That's a super old, just the inline wire. What is
the DB9? The DB9 we have. It's not that old. I mean, yes, it's old, but DB9. The DB9, but they do Profibus with M12 plugs now and 12 terminators and everything, which is nice. But yeah, this is what we're doing. We do a lot of retrofit for slip ring communication for Profibus, for steel mills, stuff like that. Profibus, because it's enterprise and industrial have one overlapping: never touch a running system, right?
Yeah.
And so if the steel mill is running since 20 years, why? And it's only the cable that's breaking. Why should we exchange it to Profinet? Why not just exchange the cable to our wireless solution?
A lot of times they only want to make a change when the hardware is no longer able to be purchased off the shelf.
Yep.
And even then I've seen them, they finally changed because they can't find old parts on eBay anymore.
Once the eBay supply runs out.
Oh yeah, I was in one facility was with this Allen Bradley PLC5 or something, and it was like, oh nope, can't help you, nope.
Good luck.
We had a like a small like carnival kind of thing come through a couple of years ago, and we had to like order off of eBay. They had some super old PLC system on there. We had to order like something off eBay to like help get them going. I mean, it was like, it's like, am I getting on that device?
Nope.
You know,
Nope. Well, Tobias, I cannot thank you enough for coming on the show. This has been awesome. I really enjoy these deep dives and understanding more of the technology. And honestly, I don't have a problem being called out when I'm wrong. So, knowing that these ranges are truly possible out of Bluetooth, I'm glad we have these conversations because, yeah, if I'm wrong, tell me. Let's put it out there. Let's learn from it and let's understand, right?
Same.
So I greatly appreciate it. Thanks so much for coming on the show. And any parting words of wisdom? Put
From
you on
my
the
side, no.
spot here.
Thank you, thank you so much for having me. Looking forward to be here again with the other stuff we just talked about, whatever that may be, and if it works out or not, maybe not. If it's not working, let's see. Thanks again for having me. Thanks again for that very nice introduction for 90 minutes of talk. I think if it wouldn't be that late, we could do it for another 5 hours. So thank you
You
again
know,
very much.
it's hard because with most of these, we could just sit there and go on and on because it's such a fun conversation. And I enjoy bringing all of this and putting it out there for everybody because these are the conversations that I learn the most from. I've discovered over the years that a good podcast is worth its weight in gold if you're learning something from it. And I've found that I actually retain more from this format than I do sitting there trying to dry read, and not having any sort of other context. When I'm hearing people talk about the standards versus real world applications of that exact thing, it means a lot more to me. And it gives me a more kind of a personable reference that imprints more in my brain, if that makes any sense whatsoever. My wife's a teacher, so she's all about learning theory and all this other crap that I can never remember the names of, but the concepts stick, so I get it. But guys, thanks again. This has been another great episode. I hope everybody comes back and joins us again for our next one. Tobias, I got a feeling we're going to have you back before too long. So good conversations are something I want to keep going.
and then where can people find you if they're looking for you or Onyx?
Oh, me, yeah. Onyx.io in this
Sorry.
interwebs. In this interwebs, it's onyx.io. Me, LinkedIn. Probably I was tagged actually in this episode's preview from Scott. Try to reach out to us. Give us a shout if you want to talk about Bluetooth or any other stuff. We are mostly in Michigan area, but we're working our way down to the Midwest and far south. So Onyx.io it is.
That's
Awesome.
awesome. All right,
Hey, when
everybody. Thanks again and have a great day. And we'll see you guys next time on the Industrial Wi-Fi Shop. Thanks for listening, everybody. And we hope you join us on our next episode of the Industrial Wi-Fi Shop.